how air is affected when heated. And then by the end of the day, I want you to be able to articulate how air pressure relates to real life experience. Okay? Okay, so this is somewhat of what I want you to do when you see this is I want you to try to think of why it's happening, and then I want you to share with a partner, and then we'll go over why it's happening in a little bit. So I'm lighting a candle. I want you to see what happens to the bag.
Is it going to light on fire?
No, it's not. Shush. Very interesting. Okay, we'll do the other.
You're tripping.
I'll do this like 5 times.
It'll work. It'll work.
Yeah, I think it's taking for a while.
It's actually working.
Lower it down a little so you don't have flame going. It may be stuck on the needle thing.
Oh, I did this back and forth.
No, I know.
Times.
It's-
The wind
it's
blew
very
it a lot
tricky.
today. Found when I held the
It's
candle
going up.
sideways,
It's
but it
going
was
up.
going like pretty fast yesterday.
It just depends.
Really?
There's a lot of drafts in here. But it's going up. It's
It
definitely
is going up.
It's more fun when it goes up a lot.
Yeah.
It's extreme.
Okay, well this is fun.
I don't.
Oh,
It is.
It's a
going the
very
wrong way.
tricky demo.
You can see it.
It's going.
It's moving.
going up.
It's moving. It's moving.
Go, go.
Go.
It is going.
We know that it's supposed to, so
Yeah, but I want to be cool. I'm wasting all my time. So
some things are very difficult to do, Ross.
I know, seriously. So anyway, it goes up.
It's a
And
very
I
tricky demo.
spent
so-
a long time trying to make that work yesterday, but whatever.
Don't worry.
So much?
I don't grade down on that because there's so
appreciate
much.
that. Thank you.
No, but there's so much draft in these places. It really affects it.
Now I need to get my little thingy back out here.
Would it kick you out again?
Kick me out, stupid. This is about 9, so we're good. Okay.
Oh, I like that.
Air pressure. We watched the YouTube video.
Cool things.
So what is air? Air is mostly nitrogen. There's some oxygen in there, and then there's carbon dioxide and other carcinogens. So now you know that.
Are there carcinogens?
Argon?
Oh, argon. Look at it.
Argon. Just kidding. Yeah, this just keeps coming up. I don't know why it is. So air, essentially, and the thing that I want you to take away from this is that we are not conscious of air's weight because we are immersed within it. And 1 pound of air is essentially what you fill up a bathtub with. So now you know what air looks like in a tub is about 1 pound.
Wow.
So barometers. So after this little interesting demonstration that we had, barometers. So if a barometer is reading that, well, let's first talk about what happened here. When heat is applied to air, it rises. It rises because it's less dense than the cold air. And we'll talk about that in a second. But so if we're applying that to real life experiences, a barometer reads high, and what does that mean as far as weather goes? Can anybody guess? If a barometer is reading high, what it means? Does it mean the weather is good or the weather is bad?
Good.
That it's good because it's the heat, right?
Right.
Okay. So today we're going to be looking at hot air balloons, just like we were looking at the paper bags. And a hot air balloon is based on the very basic scientific principle that warmer air rises and cooler air. Essentially, hot air is lighter than cooler air because it is less mass per unit of volume. The cubic foot of air weighs roughly 28 grams, And if you heat that air by 100 degrees, it weighs about 7 grams less. Therefore, each cubic foot of air contained in a hot air balloon can lifted about 7 grams. That's not much, but this is the way hot air balloons are so huge. To lift 1,000 pounds, so you need about 65,000 cubic feet of hot air. So our assignment today, we're going to have the pilot of a hot air balloon. We're going to have the scientist of a hot air balloon. We're going to have the graphic designer, and we're going to have the mechanic. So I'm going to give you, your partners are all grouped up. We've done those previously. Those are in my lesson plan. So we'll have each of you in your group come up and take. And you'll each have your corresponding assignment. Where's my little task thing? So the pilot, your job is to illustrate the responsibilities of a hot air balloon pilot. It is necessary to understand the job of a pilot in order to understand how the balloon moves through the air. The scientist is going to work with the pilot to understand the flight of the balloon using the basic scientific principles. The graphic designer is going to collect images of balloons so that your group has illustrations for the manual. You will work with the mechanic to make sure you include images that include all of the balloon components. And the mechanic, your job is to understand the essential parts of the balloon that enable it to fly. Each person in the group will create an electronic instructional manual illustrating and explaining how hot air balloons work. So that's our assignment. Once the assignment is done, which it is because you guys are all so smart and have already done it, we're going to do an exit slip. So after what we've learned today and what you've learned in your groups, how does air pressure relate to my everyday life? So let's talk about that. We've got kites, we've got barometers. Anybody else can name anything that relates to air pressure and how Airplanes, exactly. And I guess that's it. Am I okay on time?
Mm-hmm.
Oh, and I have some more information too because we talked about volume yesterday, and that was a segue into air pressure, and then we've got temperature that we're working on tomorrow. So I have this up front if anybody wants to take it home and be an overachiever. The end.